121 is another finding from consensus audit of growth DeFi related to specification and access control, where the concern was about tokens with non-standard behavior such as ERC777 callbacks, which would enable an attacker to execute potentially arbitrary code during the transaction, or inflationary, deflationary, and rebasing tokens. The recommendation was to evaluate all tokens prior to inclusion in the system. This is related to token deflation via fees in 107, token inflation via interest in 108, guarded launch via asset types in 129, and broader aspects of token handling in 159, system specification and documentation in 136 and 137, and accounting issues in 171 that we discussed in security pitfalls and best practices 201 module. 122 is another finding from consensus audit of growth DeFi related to naming convention and readability, in which the code base made use of many different contracts, abstract contracts, interfaces, and libraries for inheritance and code reuse, which is in principle a good practice to avoid repeated use of similar code, but with no descriptive naming conventions to indicate which files would contain meaningful logic, the code base became difficult to navigate. The recommendation was to use descriptive names for contracts and libraries. This is related to broad aspects of programming style, code layout, and naming convention in number 97 to 101 of Solidity 101 module, and clarity issues in 188, principle of economy of mechanism in 197, and principle of psychological acceptability in 199 that we discussed in security pitfalls and best practices 201 module. 123 is another finding from consensus audit of growth DeFi related to initialization and timing, in which many contracts allowed users to deposit or withdraw assets before the contracts were completely initialized, or while they were in a semi-configured state. Because these contracts allowed interaction on semi-configured states, the number of configurations possible when interacting with the system made it very difficult to determine whether the contracts behaved as expected in every scenario, or even what behavior was expected from them in the first place. The recommendation was to prevent contracts from being used before they were entirely initialized. This is related to broad aspects of initialization issues in 166, and also the timing and ordering issues in 177 and 178 that we discussed in security pitfalls and best practices 201 module. 124 is another finding from consensus audit of growth DeFi related to denial of service, in which there was a potential for resource exhaustion by external calls performed within an unbounded loop. For context, request flash clone performed external calls in a potentially unbounded loop, and in the worst case, changes to system state could make it impossible to execute that code due to the block gas limit. The recommendation was to reconsider that logic or bound the loop. This is related to the gas impact on denial of service in 42, 43, and 44 of security pitfalls and best practices 101 module, and broader aspects of denial of service in 176 and gas issues in 182 of security pitfalls and best practices 201 module. 125 is a finding from consensus audit of Paxos related to stale privileges and access control, in which old owners could never be removed. For context, the intention of set owners was to replace the current set of owners with a new set of owners. However, the isOwner mapping was never updated, which meant that any address that was ever considered an owner was permanently considered as an owner for purposes of signing transactions. The recommendation was to change set owners such that before adding new owners, it would loop through the current set of owners and clear their isOwner booleans. This is related to aspects of access control implementation and changes in 149 and 153, and broad aspects of access control issues in 172 that we discussed in Security Pitfalls and Best Practices 201 module. 126 is a finding from consensus audit of Aave V2 related to potential manipulation of interest rates using flash loans. Recall that flash loans allow users to borrow large amounts of liquidity from the protocol, because of which it was possible in Aave to adjust the stable interest rate up or down by momentarily removing or adding large amounts of liquidity to reserves. Given that this type of manipulation is difficult to prevent, especially when flash loans are available, the recommendation was for Aave to monitor the protocol at all times to make sure that interest rates were being rebalanced to sane values. This is related to aspects of flash loans in 120 and scarcity in 186 and auditing and logging issues in 173 of Security Pitfalls and Best Practices 201 module. 127 is a finding from consensus audit of Aave governance DAO related to validation, in which the concern was that because some protocol functionality relied on correct token behavior, problems could arise if a malicious token were to be whitelisted, because it could block people from voting with that specific token or gain unfair advantage if the balance could be manipulated. So the recommendation was to make sure to audit any new whitelisted asset. This is related to aspects of carded launch via composability limit in 132, token handling in 159, external interactions in 180, and dependency issues in 183 of Security Pitfalls and Best Practices 201 module. 128 is a finding from consensus audit of Aave CPM related to specification and validation, where there was a risk of integer underflow if token decimals were to be greater than 18, because in latest answer function, an assumption was made that token decimals was less than 18. The recommendation was to add a simple check to the constructor to ensure that the added token had 18 decimals or less. This is related to dangers of integer overflow underflow we discussed in number 19 of Security Pitfalls and Best Practices 101 module, and system specification and documentation in 136, 137, and broader aspects of data validation in 169, and numerical issues in 170 of Security Pitfalls and Best Practices 201 module. 129 is another finding from consensus audit of Aave CPM related to testing of Chainlink's performance at times of price volatility, where the recommendation was that in order to understand the risk of Chainlink Oracle deviating significantly, it would help to compare historical prices on Chainlink when prices were moving rapidly and see what the largest historical delta was compared to the live price on a large exchange. This is related to the broad aspect of testing in 155, external interaction in 180, and freshness issues in 185 that we discussed in Security Pitfalls and Best Practices 201 module. 130 is a finding from consensus audit of Lien protocol related to configuration, where the concern was that the system had many components with complex functionality leading to a high attack surface, but no apparent upgrade path if any vulnerabilities were to be discovered after launch. The recommendation was to identify which components were crucial for a minimum viable system, to focus efforts on ensuring the security of those components first and then moving on to others. Also, to have a method for pausing and upgrading the system, at least at the early phases of the project. This is related to the various guarded launch approaches in 128 to 135 and the broader principles of economy of mechanism and work factor in 197 and 200 of Security Pitfalls and Best Practices 201 module. 131 is a finding from consensus audit of balancer protocol related to code factoring, where it is generally considered error prone to have repeated checks across the code base, and therefore it was recommended to use modifiers for common checks within different functions because that would result in less code duplication and increased readability. This is related to function modifiers in 141 and broader aspects of clarity in 188 and cloning issues in 190 of security pitfalls and best practices 201 module. 132 is another finding from consensus audit of balancer protocol related to ordering, where bpool functions used modifiers logs and lock in that order. Because lock is a reentrancy guard, it should have taken precedence over logs in that order to prevent logs from executing first before checking for reentrancy. So the recommendation was to place lock before other modifiers to ensure that it was the very first and very last thing to run when a function was called, because recall that the order of execution is from left to right for modifiers. This is related to function modifiers in 141, incorrectly used modifiers in 152, and broader aspects of ordering in 178 and business logic issues in 191 of security pitfalls and best practices 201 module. 133 is a finding from consensus audit of MCDEX V2, where the concern was code-based fragility. Software is considered fragile when issues or changes in one part of the system can have side effects in conceptually unrelated parts of the code base. Fragile software tends to break easily and may be challenging to maintain. And therefore, the recommendation was to prioritize two concepts. One, follow the single responsibility principle for functions, where one function does exactly one thing and nothing else. And two, reduce reliance on external systems. This is related to broad aspects of external interactions in 180, dependency in 183, clarity in 188, and principle of economy of mechanism in 197 of security pitfalls and best practices 201 module. 134 is a finding from Taylor-Bitts audit of liquidity protocol, where the concern was that reentrancy could lead to incorrect order of emitted events because there were events emitted after external calls in some functions. In the case of a reentrant call, such events would be emitted in the incorrect order. That's the event for the second operation would be emitted first, followed by the event for the first operation, causing any off-chain monitoring tools to have an inconsistent view of on-chain state. The recommendation was to apply the checks effects interactions pattern and move the event emissions before the external calls to avoid any effects of potential reentrancy. This is related to reentrancy vulnerabilities in number 13 of security pitfalls and best practices 101 module, along with broader aspects of timing issues in 177 and auditing logging in 173 that we discussed in security pitfalls and best practices 201 module. 135 is a finding from Taylor-Bitts audit of origin dollar, where the concern was that variable shadowing in OUSD from ERC20 could result in undefined behavior. For context, OUSD inherited from ERC20 but redefined the allowances and total supply private state variables, because of which accessing those variables could lead to returning different values from what was expected. Note that these were private state variables, and so the one in ERC20 was not visible in OUSD, and the concern was more of developer clarity than the variable scope and visibility. The recommendation was to remove the shadowed variables in OUSD. This is related to state variable shadowing in 106 and 136 of Solidity 201, where we saw that Solidity version 0.6.0 made state variable shadowing an error, where the same named state variables were visible or accessible in both base and derived classes. This is also related to the broad aspect of clarity in 188 of Security Pitfalls and Best Practices 201 module. 136 is another finding from TaylorBit's audit of Origin Dollar, where the concern was about error handling because vault core rebase functions had no return statements. For context, vault core rebase functions were declared to return an UN but lacked a return statement. As a result, these functions would always return the default value of 0 and were likely to cause issues for their callers. Third-party code relying on the return values might therefore not have worked as intended. The recommendation was therefore to add the missing return statements or remove the return type in those functions and then adjust the documentation as necessary. This is related to function return values in 142 and error reporting issues in 175 of Security Pitfalls and Best Practices 201 module. 137 is another finding from TaylorBit's audit of Origin Dollar, where the concern was about multiple contracts missing inheritances. Multiple contracts were the implementations of their interfaces, inferred based on their names and implemented functions, but did not inherit from them. This behavior is error prone and might lead the implementation to not follow the interface if the code were to be updated. The recommendation was to ensure that contracts inherit from their interfaces. This is related to unused constructs in 156 and undefined behavior issues in 179 of Security Pitfalls and Best Practices 201 module. 138 is a finding from TaylorBit's audit of yield protocol, where the concern was that Solidity compiler optimizations could be dangerous. Yield protocol had enabled optional compiler optimizations in Solidity, but there have been bugs with security implications related to such optimizations. Solidity compiler optimizations are disabled by default, therefore it was unclear how many contracts in the wild actually used them and how well they were being tested and exercised. So the short-term recommendation was to measure gas savings from optimizations and evaluate the trade-offs against the possibility of an optimization-related bug. And in the long term, monitor the development and adoption of Solidity compiler optimizations to assess their maturity. This is generally related to Solidity versions in number 1 and compiler bugs in 77 to 94 of Solidity 101 module, and dependency issues in 183 of Security Pitfalls and Best Practices 201 module. 139 is another finding from TaylorBit's audit of yield protocol, where the concern was that permission granting was too simplistic and not flexible enough. For context, the yield protocol implemented several contracts that needed to call privileged functions from each other. However, there was no way to specify which operation could be called for every privileged user. All the authorized addresses could call any restricted function, and the owner could add any number of them. Also, the privileged addresses were supposed to be smart contracts, but there was no check for that. And moreover, once an address was added, it could not be deleted. Therefore, the recommendation was to rewrite the authorization system to allow only certain addresses to access certain functions. This is related to access control and trust issues we discussed in 148, 149, 160 and 172, and principles of least privilege in 192 and principle of separation of privilege in 193 of Security Pitfalls and Best Practices 201 module. 140 is another finding from TaylorBit's audit of yield protocol, where the concern was that there was lack of validation when setting the maturity value. For context, when a FI die contract was deployed, one of the deployment parameters was a maturity date passed as a Unix timestamp. This was the date at which point FI die tokens could be redeemed for the underlying die. The contract constructor, however, performed no validation on that timestamp to ensure that it was within an acceptable range. As a result, it was possible to mistakenly deploy a wide-eye contract that had a maturity date in the past or many years into the future, which may not be immediately noticed. The recommendation, therefore, was to add sanity and threshold checks to the wide-eye contract constructor to ensure that maturity timestamps were within an acceptable range to prevent maturity dates from being mistakenly set in the past or too far into the future. This is related to system documentation in 137, function parameter validation in 138, and broader aspect of data validation issues in 169 we discussed in Security Pitfalls and Best Practices 201 module.